events, and I am Lauren, so that's that. So here are some helpful formulas that would be good in this situation. Should I just read them all, or just say? Okay, so the top one here is for just the union of two events, and if they're mutually exclusive events, that's what you use without subtracting the intersection of them. There's also for independent events, but that's not my topic. I just figured I'd put it there just for fun. And that is a probability that an event will not happen, given that one has already happened. So this question is, if a drug meant to cure an infection has a probability of working, P of W 87% of the time, then what is P of W, P of not W? So does anyone possibly remember this from last year? Yeah.
Wouldn't you do like 100% minus 87%?
Yeah. Basically, I just changed it into decimal. So yeah, same thing. So you use the complement formula, and so I made it into a decimal by shifting it over 2, and then subtract it from 1, and you get 0.13 or 13%. And circle your answer. One card is selected from a standard deck of 52. What is the probability that the card is either a heart or a face card? So I don't know if you guys remember from last year, but it's helpful to have a picture or Venn diagram type thing. So this is helpful. So either a heart or a face card. So you look at the probability that it's a heart, and there are 10 of them plus the 3 in the middle that are both, so 13 out of 52. And then you would add that probability it's a face card, which there's 9 of them down there, plus 3 is 12 out of 52. So then you would add, let's see if I have that, yeah, 2 seconds. Awesome. And then you would subtract the intersection where they both connect, which is that center part, so the 3 out of 52. And you'd get 22 out of 52, which would be simplified to 11 over 26, which is then circled. So if you flip 2 coins at the same time, what is the probability of getting 1 head and 2 tails? So anyone really know what figure we could use that could help with this?
Tree diagram or
table or something? Maybe a table. I think a table sounds nice. So, there's a nice table there.
Square.
Yeah, Punnett square from biology, just with coins. So since these 2 events are exclusive, you can't have them at the same time because a coin only has 2 sides. So you would say the probability of just getting 1 head, and if you get 1 head, you have to have 1 tail with it. So a head and 1 tail, there's 2 options. You have in the top right and the bottom left. And then the probability of getting 2 tails is only once. So the top left. So you would just simply add those 2. You get 3/4, and you circle your answer. Okay. A bag contains 9 red marbles numbered 1 to 9 and 6 white marbles numbered 10 to 15. If 1 ball is drawn at random, what is the probability that the number on it is divisible by 4 or red? So since it's or, you use union, and these are not mutually exclusive. So first you see the probability that it is divisible by 4. So you see that it's really 1 through 15. There's 3 numbers. You have 4, 8, and 12, so you know that is 3. Did it go? Yeah. And then that it's red, they tell you that there are 9 red marbles, so that's that. And then if it's both divisible by 4 and red, on numbers 1 through 9, there are 2. You have 4 and 8, so it'd be 2 out of 15. So you just add 3 out of 15 plus 9 out of 15 minus 2 out of 15, and you get 10/15ths, which is then simplified to 2/3 and circled. And then here, just to review the helpful formulas, you have the union at the top, mutually exclusive second, independent, which is not my topic, and the complement formula. And that's that. We have a very nice assessment. Very good.